Hello everyone. In this video, we try to solve the question subarray with zero sum. So what is given in the question? We are given an array of positive and negative numbers, and we have to find if there is a subarray of at least one size which has sum equals to zero. So what is given in the question? So we are given an array. Okay, we are given an array. Let's suppose 4, 2, minus 3, 1 and 6. This is the given array, test case array. So what we are given an array. We have to find a sub array in this array. Sub array is basically a continuous part of an array. Okay, continuous part of an array. That means that consists of one or greater than one array element. That means this is a subarray, this is a subarray, this is a subarray, this is a subarray, this is a subarray. This is a subarray. So a continuous part. This is a subarray. This is a subarray. This is a subarray. So subarray is a continuous part of an array that consists of one or more than one array elements. Okay. So we have to find the sum of a subarray that is equals to sum of a subarray is equals to zero. So this is a particular question, and now how can we approach this question? So now we look at the naive approach. If we consider every element iterate over the array, and for this element we traverse for the whole array. We traverse the whole array and try to find the cumulated sum. If at any particular time the cumulated sum become equals to zero, that means there is a subarray that contain its sum as zero. So basically what I am trying to say, if we consider this array, we have the current sum for this position as 4. When we reach this, we have our current sum as 6. When we reach this point, we have current sum as 3. For this point, current sum as 4. And from this point, current sum as 10. So we do not find any position where current sum become equals to 0. So we start considering from this point. For this point, the current sum is equals to 2. Then if we add current sum into this array element, then we have minus 1, our current sum. Then for when we add this array element, we have our current sum as 0. That means we have found our answer and will return true. That we have a sub array that has its current sum that starts here and ends here and has its current sum as 0. So if index is asked, then what we'll do, we have this particular index, we'll return j minus I plus 1, that is the length of the subarray. And if we are just asked to return a boolean value, that is true or a false, we'll return this one. So this is a naive approach. We look at the naive approach. For every element we find the cumulative sum, and if the cumulative sum at any point become equals to 0, ठीक है, then we'll return true, otherwise false. Or if we are asked to find the length of the subarray, then what we can do, we can easily find it by returning. If there is a case where a sum become equals to 0, we'll return j minus, that is the index, that is the index for the nested loop, that is j minus I plus 1. Okay, so this approach takes order of n squared time for traversal of the array because we are using two nested loops. So it requires a time complexity of big O of order of n square and space complexity of big O of 1 because we are not requiring any auxiliary space. Okay, so we do not have any space complexity here. Now, can we optimize this approach? Yes, we definitely have to optimize this approach. So what is the optimized approach? So in this approach, first thing we have to analyze is, if let's suppose there is an array and the sum of the array element till this particular array element is s. Okay, till this particular array element, let's suppose we have three array elements and the sum of this array elements are s. And we also have one more point here. Till that point, the sum of array element is also S. That means that the sum of the array element between these 2 points will be equals to 0. That particularly means that there exists a subarray with sum 0 between these 2 points. This is the particular intuition. Let me tell you one more time. If there exists a point, let's suppose there is an array and the sum of the array element till this point is equals to S. Okay, and the sum of the array element till this point, this particular point, let's suppose this is at index 2 and this is at index 6, let's suppose. Okay, so the sum of the array element takes till position 2 is S and till position 6 is also S. That means that the sum of the array elements between third to sixth index, the sum of the array elements is equals to 0, because the reason for getting the sum equals to S from 0 to 6 is because we are finding a subarray that has the sum 0, because we have previously found the sum of the subarray till this point as S. And if we find another time the sum of the subarray, the cumulated sum as S, that means that there are there is a subarray in between these 2 points whose sum will be equals to 0. So this is the particular intuition we'll use in this question. So what we'll do, we'll traverse the array. This is the particular intuition we'll use. We traverse the array from left to right and find the cumulated sum. Okay, we find the cumulated sum, and if the cumulated sum become equals to 0, we will return true. So it is a fair condition. Okay, fair condition. If from the 0th index to a particular ith index, if we are finding the sum as 0, then this is a subarray that has its sum as 0 will return true. So it is a normal condition. Okay, normal condition. Now here our intuitions come into play. For every iteration, we will check if the current sum is present in the hash set. So for every iteration, we will be storing the current sum, the cumulated sum, in the hash set. Okay, hash set. So we are storing and at every iteration, we will check if the current sum is present in the hash set. If it is present, that means that sum has previously been existed. मतलब कि अगर वो जो करंट सम है, if the current sum is previously been existed in the hash set, that particularly means we have encountered that sum for previous elements and we are still getting our current sum as S. So there might be a sub array, there would be a sub array that has its sum equals to 0 between these 2 points. Okay, so that particularly means when we find an element in the hash set, we will return true. Okay, we will return true. That means that there exists a subarray that has sum equals to 0 and we will return true. Okay, we will return true. Otherwise, for every iteration, we will be storing the cumulative sum in the hash set. So it is this procedure will be repeated for every iteration until we get our answer. And if we do not get our answer at the end of the loop, we will return false. Okay, we will return false. Now, what is the time complexity in this case? The time complexity will be order of n, because we are traversing the array in the linear time and finding the cumulative sum, and we are using a hash set. So at the worst condition, we have n elements stored in our hash set. So the space complexity should be big O of n and the time complexity should be big O of n. Okay, so I will show you the demonstration how this algorithm is working. Okay, so at the first iteration, we'll have our current sum as 4, and we'll check in our hash set. And we'll check in our hash set. So let me analyze it here. Okay, we have 4, we have 4, we have 2, we have -3, we have 1, and we have 6. And this is our hash set. Currently, our current sum is equals to 0. Hash set is empty. Okay. Now, what we do, we find a cumulative sum. The cumulative sum become equals to 4, and we'll check in the hash set if this sum exists in our hash set. No, it doesn't existed. So for every iteration, we'll store this in our hash set. So this is after first iteration. Then we again find the cumulative sum. Now it will become 6. We check in our hash set if this cumulative sum existed in our hash set. No, it does not exist. So for every iteration, we'll store it in the hash set. For the next element, we'll find the cumulative sum. It will become 3. Is 3 exist in our hash set? No, it does not exist. That particularly means that we have not encountered this sum previously. So we'll store in our hash set for every iteration. Then we again find the cumulative sum for the next element. We'll find the cumulative sum as 4. Now we again check if this sum existed in our hash set. Yes, this existed in our hash set. That particularly means we have a subarray that exists between these particular two array elements and has its sum equals to 0, and at this particular condition we'll return true. Okay, so this is the working. When we just have to show, we have to return a boolean value. If there is a condition, we have to find the longest subarray. We have to find the longest subarray with sum equals to 0. Okay, at this condition, it is just the modification of the discussed approach. In this condition, what are the modification we have to do? We have to use a hash map instead of a hash set. Okay, instead of a hash set, we are going to use a hash map. Okay, why we are using a hash map? Because we, for a particular element, we gonna insert its index also. So we insert in our hash map value corresponding to the index, because at the second time, if we encounter the same current sum, we will find the length of the subarray as the index we have encountered and index at which it has been previously encountered. So I will show you a test case, and then I will tell you. We have one test case, 4, 2, -3, 1, and 6. So this is our array. Now we have to return the longest subarray with sum equals to 0. Okay. Now current sum at this position is 4. We have our hash set. Okay. Now we have a hash set. Okay. We have a hash. Initially our current sum will be 0. For this particular element, we find the current sum, cumulative sum as 4. We check in our hash set, is this value existed, hash map, sorry, hash map, if this value existed. No, it does not exist. So we inserted its value with its index. So its index is 0. We insert it with its index. Okay, now we move to the next element. We find the current sum, cumulative sum. Cumulative sum become equals to 6. We will check in our hash map, is this sum exist in it? No, it does not exist. So for every iteration, we will store the cumulative sum corresponding to its index. That's so easy. We again find the cumulative sum. Our cumulative sum now become 3. Now become 3. We check in our hash map if this cumulative sum exists in our hash map. No, it does not exist. So we store this current cumulative sum corresponding to its index. Now we move to the next element, find the cumulative sum. find the cumulative sum as 4. Now we'll check if this sum existed in our hash map. Yes, it existed in our hash map. Now, how will we find the length of the subarray? So, at the previously existed sum, we can obtain its index. So, we previously obtained this sum at index 0. Okay, and for this particular sum, we have obtained it on index 3. So we'll get the length of the subarray by subtracting this particular index at which we have find the equal cumulative sum. We'll return this. Okay, we'll return this. That is the currently find index. Okay, and the previously find in the hash map. Okay, and that condition that from 0th index to the ith index condition would remain same. If the current sum become equals to this current sum become equals to 0, if current sum become equals to 0, and in this condition we will return the index plus 1 length. Okay, and otherwise we uh, if we obtain our answer using this particular intuition, we'll get we'll subtract the index of the current find cumulated sum that is equals to the previously stored cumulated sum that is in our hash map. So from this particular index, we'll subtract this particular index. So this approach also requires a time complexity of order of n and space complexity of order of n. Okay. So these are the two questions that are based on subarray with sum 0. Okay. Now I will show you the code pseudo code for one of these that check if there exists a subarray with sum equals to 0. So we will have our unordered set. We have our cumulative sum. For every iteration, we will calculate the cumulative sum. If the cumulative sum become equals to 0, we directly return true. Otherwise, we check in our hash set hash set if this value current sum value exists in a hash set, will return true. Otherwise, for every iteration we'll insert the current sum cumulative sum in our essay. Otherwise, if these two conditions does not match, after this loop will end, we'll return false, because there might not be any possibility that there exists a subarray with sum equals to 0. So here we have solved two important questions, okay, that are commonly asked in Amazon interviews. Okay, so here I end this video. If you have any doubt, please feel free to ask, and bye bye.